Hey guys, let's discuss this system today. So we have an inclined plane and there is a mass on the inclined plane. Okay, and the mass is connected to a massless pulley. We'll take the pulley as massless, and then the string is also massless, and the string is connected to a hanging mass. Okay. Now we'll assume that this surface has friction. Okay. So we'll assume that the system is moving and the acceleration is in this direction. Okay. And there is friction. Okay. So it's a rough surface, in other words. Now let's call this guy M1, this is M2. Okay. Let's look at the forces acting on these masses. There is of course the normal force. Okay, so let's call this N1. And then there is, so the system is moving in this direction, right? So then there is the frictional force, okay, and then there is tension. Okay, now this is tension. Now the pulley is massless, so of course weight. Okay, now the pulley is massless, so we don't need to, the tension is going to be the same. We did an example in which we had a flat surface and pulley, a massive pulley, where we had to consider the moment of inertia. So if the pulley is massive, then the tension is different. So in this case, since the pulley is massless, the tension is the same. Okay, so tension T over here as well, and then the weight of this object W2. Okay, so these are the forces acting on the system. Let's write Newton's second law for the two masses. So here we go. Let's do M1 first. So M1. So there is acceleration. Okay, so F net, Newton's second law says that F net equals mass times acceleration. Okay, now in order to write Newton's second law, we need to know the components of the weight, right? So this is, of course, we need to know this component. Okay, let's call this angle theta. Okay, and we need this component. So we have discussed in a previous video from geometry that if this angle is theta, then this angle will also be theta. Okay, so this is theta. So therefore, this is W cosine theta, and this guy over here is W sine theta. Okay. The side opposite to the angle always has a sine. The side adjacent always has a cosine. Okay. So we now know the components. Okay. So W sine theta, you can show it over here as well. So W sine theta can be shown over here as well. Okay. W. Okay, yeah, I should use that subscript W1, okay, because we're differentiating the masses. So then if you write in second law, you get T minus W1 sine theta minus Fk equals M1 times A. Okay, this is your X equation. This is our x-axis, this is our y-axis for this mass. Okay? And if you want to write the y equation, you get N1 minus W1 cosine theta. So since there's no motion along the y direction, right? The net force, according to second law, is 0 in that direction, right? So you get this equals 0. So this is your y equation. So this is your M1. Okay, let's look at M2. Mass M2. So for the mass M2, there's only y equation. It's simple. It's just W2 minus T equals M2A. Okay, so it's just the y direction, and the equation is simple. So you get W2 minus T equals m2 times a. Okay. Now we have the equations from Newton's second law for the two masses. Okay, so let's call this equation 1, this equation 2, this equation 3. Okay. Now we need to solve these three equations together. Okay. So let's look at equation 1 first. Okay. So now let's solve 1, 2, and 3. So 1 is t minus w1 sine theta minus, now the kinetic frictional force is mu k, the coefficient of kinetic friction, times the normal force n1 equals m1 times a. Okay. Now you can see from equation 2, okay, so we can use equation 2, use 2 to and you can plug it into 1. Okay, so you get t equals t minus w1 sine theta minus mu k times w1 cosine theta equals m1a. Okay, so you can call this equation 4. Okay, you can call this equation 4. Now let's add. Now you can see now we need to get rid of tension, because we need again our answer in terms of the variables, and then in terms of the variables we typically know the masses, the angle, right, and the coefficient of kinetic friction. So we can add 3 and 4 to get rid of tension. And you can see that if we add, the tension cancels out, right? So add 3 and 4. So when you do that, you get w2 minus w1 sine theta minus mu k w1 cosine theta equals m1 plus m2 times a. Okay, so that's your, you can see now we can divide both sides by m1 plus m2. Acceleration becomes w2 minus w1 sine theta minus mu k w1 cosine theta divided by m1 plus m2. So that's your acceleration for this system. Okay, now you can of course use w equals mg. Okay, but before we do that, let's look at some interesting things about this this equation. We'll plug in some numbers. I have some sample numbers that we'll plug in to get a feeling of to get a numerical feeling of the problem. But the usefulness of deriving it in terms of these variables is that you can plug in different angles and see if your formula makes sense. So let's see if theta, theta is this angle, right? Now if theta is equal to 0, you're bringing your plane, you're making it flat, right? You're making it horizontal. It's actually the problem that we've discussed before without friction. So if theta is equal to 0 degrees, right, then you can see that sine 0 is 0, right, and cosine 0 is 1. So the equation becomes a equals w2 minus mu k w1 divided by, this is mu k, m1 plus m2. So you can also write this as m2 minus mu k m1 divided by m1 plus m2 times g, where I've just plugged in w equals mg for both m1 and m2. So this is just this system, that the theta equals 0 condition, right? It reduces it makes the system like this. Okay, this is the system that we now know the acceleration of, because now theta equals 0. Okay, so the formula reduces to interesting cases. Another interesting case, very interesting case, which I really like, is the theta equals 90 degree case. So if you make theta 90, you're making it perpendicular to the ground, right? So you can see that if theta is 90 degrees, then cosine 90 is 0. So the block actually loses contact with the surface. It actually, interestingly, becomes an Atwood machine. Okay. So for theta equals 90 degrees, okay, so you can plug in 90, so you get W2, sine 90 is 1, so you get W2 minus W1. Cosine 90 is 0, so this, you get rid of this. And this stays the same. So you get A equals W2 minus W1 divided by M1 plus M2. Yeah, that's it. So this is just the Atwood machine that we have studied before. It's very interesting. Now this becomes an Atwood machine. It became this system now. Okay, essentially this system. So this was the two special conditions for the angle. Let's take some sample numbers. Let's go back to this equation. Okay. Let's go back to this equation. And now let's assume that we have some numbers for the masses. Okay. So I'll just rewrite this down over here so that we know that we're not using any special condition. We're just using the general formula now. Okay. Now let's assume that M1 is 20 degrees. Let's see, take easy numbers. M2 is 30. M1 is 20 kilograms. M2 is 30 kilograms, and theta is 30 degrees. Okay. So acceleration now, and of course g is 9.8 meters per second squared, right? So remember that w is equal to mg. So you can plug in all these over here, and when you do that, you will get acceleration to be 2.56 meters per second squared. Okay, for these numbers. And you can also find tension. You can also find tension using this equation, using equation 3. Okay, tension is equal to W2 minus M2A. Now we now know that A is 2.56 meters per second squared. You can use your calculator to find that tension is equal to 217 newtons. So that gives you a feeling for the numbers, and we can further go deep into this, and let's say that you release this system, and the system starts with 0 velocity. You can use this acceleration, assume that it's just to give you a feeling on how to use, since you have an acceleration. Let's say that you release the system and the system starts with 0 initial velocity, right? Then you can use Vf equals Vi plus At to get the velocity of the system after time t. But anyway, this is the important thing that we got, and you can further solve this if you know numbers. We don't know these numbers, so this is just an example on how you can go forward if you know acceleration and someone asks you the velocity after time t. Okay, so this was this system, very interesting system. If you like the video, press the like button and make sure you subscribe. And if you have any questions, please post them in the comments. Thank you for watching.